This is a pre-calculus question on matrix multiplication. Remember, to multiply two matrices, matrices are always defined by the number of rows by the number of columns. And if I'm multiplying that by another matrix with some rows and some columns, let's say this is matrix 1 and this is matrix 2, then the inner numbers must be the same. The columns of the first matrix must be the same as the number of columns of the first matrix, must be the same as the number of rows of the second, and the result will have the number of rows of the first by the number of columns of the second. So this one asks for B times A. So B is a 3 rows and 2 columns. A is a 3 rows and 3 columns. Can I multiply those together? 3 by 2, and I'm multiplying it, the dot product. B by A, 3 by, it's a 2 by 3. Why didn't you correct me on that? This is a 2 by 3. And this is a 3 by 3. Okay. We'll get there eventually. B times A, 2 by 3 times a 3 by 3. I knew they could be multiplied, and when I wrote it wrong, it was not going to come out to be able to be multiplied. So the inner numbers are the same, and the result is going to be a 2 by 3 matrix, which is 2 rows, 3 columns. So let me actually do the multiplication, and I will rewrite or recopy these matrices in the proper order so it will be easier to keep track of this. Normally, all of this kind of stuff is done in a calculator, but it's good to be able to know how to do it by hand. So it's going to be B times A. I'm just moving them over here so I have them in the correct order, and in fact I don't need that letter A. I'm just going to take the thing and put it here. Okay, so remember, to multiply matrices, I go across the row of the first times down the column. Across times down, and I add the numbers. So in the first position, it's going to be 9 times 1, which is 9, minus 5 times 0, which is 0, and I'm just adding them together. Negative 2 times negative 4, which is 8. 9 plus 8 is 17. Now I go to the second. I'm going to still multiply the first row by the second column, and it's going to go in the second column on the first row of the result. 9 times 3, 27. Negative 5 times 6, negative 30. Negative 2 times 1, negative 2. That is negative 5. I just add them together. Now I'm going to do the last position, which is the first row times the third column. 9 times negative 2, negative 18. Negative 5 times negative 1, 5. Negative 2 times 7, negative 14. And so I get negative 18 and negative 14 is negative 32. That's supposed to be a 4. And negative 32 plus 5 is negative 27. All right, so now I'm going to get the second row, which I'm going to take the second row of this, multiply by the first column. That's going to be in this position, the first column of the second row. 0 times 1 is 0. 3 times 0 is 0. 8 times negative 4 is negative 32. So that number is going to be negative 32. And then I'm going to get 0 times 3 is 0. 3 times 6 plus 18. 8 times 1 is 8. 18 plus 8 is 26. And then for the last spot, it's going to be 0 times negative 2 is 0. 3 times negative 1 is negative 3. 8 times 7 is 56. And that's 53. And so this is the matrix. It's 17, negative 5, negative 27, negative 32, 26, 53. And let me double check this. 0 times negative 2 is 0. 3 times negative 1 is negative 3. 8 times 7, 56. So that's what the matrix can look like. When you're doing homework, check it on a calculator. And in fact, 17, negative 5, negative 27, negative 32, 26, 53. So my answer is correct. I just entered them on Desmos. You can also do it on a TI 84, 84 plus, whatever calculator. So that's how you do matrices, across by down. And this is the key. The columns of the first, the number of columns of the first must be equal to the number of the rows of the second. And the result will have the number of rows of the first by the number of columns of the second. So here's an example, just a very quick example. What if I wanted to multiply A times B? A times B. Well, let me look. A is 3 by 3, and B is 2 rows and 3 columns. And notice now, the middle number not the same. So I cannot multiply matrix A times matrix B. I can multiply matrix B times matrix A. In matrix multiplication, order matters.